Hello everyone, welcome back. Here is vanAmsen, and today we got something really interesting for you. We are going to solve medium level coding problem that involve binary tree and depth first search. So this one called 1372, longest zigzag path in a binary tree. So if you're looking to brush up your coding skill or have a technical interview coming up, this video is for you. So make sure to stick around till the end, because we are not just solving this problem in Python, but I will also provide the code in other languages in the description below. So, and obviously, let's dive. So first, let's understand the problem. We are given a binary tree, and our task is to find the longest zigzag path. So a zigzag path starts at any node, and you can go either left or right, but then you must switch direction at each node. And the length of the zigzag path is the number of nodes visited minus 1. For instance, considering a tree given in example 1, the longest zigzag path here is 3, which go like this. So it's go right, left, and right. You can see it. So it consists of 4 nodes, but the length is only 3. So it's right, left, and right again. So great. Now let's switch to our coding and implementation. So here we are in our coding space, and we have a solution, a class, and longest zigzag function. So now we need a helper function to perform the depth first search, or DFS. Let's start implementing it. So max length will be 0, and now define our DFS of node and direction, length, and non-local max length, and if not node, return. Let's take a moment to understand this. So we have a node as the current node, and direction to indicate whether we are moving left or right. So 0 for left and 1 for right. And length to keep track of the current zigzag path length. So, and then update the maximum zigzag length. So it will be max length equal max length, and if the current direction is 0 left, move left child and change direction to 1 right. Okay, and if direction equal 0, DFS node left 1 length plus 1, and DFS node right 0 and 1. So if current direction is 1 right, move to the right child and change direction to 0. So else it will be DFS node right 0 length plus 1, and DFS node left 1 1, and finally we are calling our DFS from root 0 0 and return max global length. So there you have it. The DFS function is complete, and finally we are calling our DFS from root to process it. So let's test it out to make sure everything works as expected. So I'm running it for this test case and also the second test case. So yeah, here all looks good. Length of 3. We can check also the second example. So it's length 4. So it's left, right, left, right. So now let's submit it. So Sometimes it passed examples, but didn't pass unseen test cases. But in our case, all good. We beat 82% with respect to runtime, so it's quite good, and also 25% with respect to memory. So, and as I promised, check the link in the description for implementation in other languages. So logic could be translated into Go, Rust, C++, and more. And that's it for this video. I hope you found this video informative and engaging. And if you did, make sure to hit the like button and share it with your friends. And if you have any questions or thoughts, drop them in the comment section below. And until next time, keep practicing, keep coding, happy coding, and see you next time.